Alright, ladies and gentlemen, this is a unit review for Unit 2. It is on page 83. It begins on page 83. You're going to do vocabulary review first. We've been working really hard on vocabulary. You're going to choose the correct word to complete each sentence. Compatible number, estimate, round, decompose, expanded form. Those are the 5 words that you're going to use for these 5 vocabulary going down through here. Number 1, when you blank add-ins, you break them apart. When you blank add-ins, you break them apart. Go ahead and choose your answer there. Number 2, you can blank an answer when you do not need an exact answer. You can blank an answer when you do not need an exact answer. Number 3, when you blank a number, you find a number that is close to the original number. When you blank a number, you find a number that is close to the original number. A blank is a number that is close to a number but is easy to work with. And number 5, the representation of a number as a sum of the values of each digit is called blank. Now that you've answered every one of them, we're going to go back and show you what the correct answer should be. When you blank add-ins, you break them apart. This is going to be decompose. You can blank an answer when you do not need an exact answer. That is going to be to estimate. When you blank a number, you find a number that is close to the original number. That is round. A blank is a number that is close to a number but is easy to work with. That is a compatible number. Remember how we made 10 and made 20? The representation of a number as a sum of the values of each digit is called blank. It is expanded form. Alright, go ahead and flip that page. You're on page 84 now. Number 6. Which is the standard form of 3,840? So we're looking for 3,000. So that means this will go out because there's nothing in the thousands place. This has 3,000, this has 3,000, and this has 3,000. 800, this one has 400, so that one's out. This one has 800, and this one has 800. And then 40, this has 4. So therefore it has to be D. Has to be D. Number 7, circle the choice that correctly shows rounding to the nearest 10. So we're rounding to the nearest 10. If I have 784, does it round to 785? If we're rounding to the nearest 10, absolutely not. It's got to end in a 0, remember? 563. So we're either going to round this number to 560 or 570. And it does round to 560, so therefore it's correct. 492. So we're either going to round it to 490 or 500. But since it's a 2, it doesn't round up to 500, it rounds to 490. 535. So it rounds up to 540. So therefore the only correct answer is 563 that rounds to 560. Number 8. It says, complete the following using properties of addition. So we're using properties of addition. So if we look at this, we know that equal sign means it's balanced. So if we have 621 here, there's 621 here. So the other one has to be 289. Now looking at this one, here's our equal sign. So what is before the equal sign has to be the same as what's afterwards. So 78, 78. 212, 212. So therefore, 418 is the only one that needs to go there. 10. Sasha spent 284 minutes swimming the first week and 247 minutes the second week. What is an estimate of the total time Sasha spent swimming? Explain your reasoning. Okay. So if we were going to estimate, 284 is close to 280. So I can round that to 280 if I wanted to. And 247, I could round that to 250. And then if I add both of them, because it wants an estimate of the time that was swimming, I would have 530. So 530 minutes of swimming. Now, if I wanted to round it a different way, because 284 is close to 300, and 247 is close to 250, then I could round it, or then I can add those two numbers and get 550, which is still a close estimate. Now this one's going to be closer to the actual total because we rounded to the nearest 10 instead of rounding to the 100 here. Moving on. Will the sum be even or odd? Write even or odd. The sum of two numbers that are both odd will be what? So if we had two numbers, so let's have 3, which is odd, and it says both of them have to be odd, and the sum is addition. So if I add 3 plus 3, it's going to be 6, and that's an even number. Let's try 5 plus 5. That's 10, so that's an even number. So if you add an odd to an odd, it's going to be even. The sum of an odd number and an even number will always be. So think about this. The sum, that means the answer to an addition problem, of an odd number, so if we use 3 as an odd number, and an even number, so we know that 4 is an even number, it's going to be 7. How about if we have 3 plus 6? It's going to be 9. So those numbers are odd numbers. So an odd plus an even is always going to give you an odd number. Use partial sums to help you find the sum. So you should have said 500 plus 400. Then there's no 10s in the second one, so it's 0 plus 70. And then it's 6 plus 2. So I have 970, and then 8. So my answer would be 978. On 14. Decompose one number to help find the difference. Okay, so on this one, I'm just going to have you answer the subtraction problem. You can do it any way you want to do it. If you want to do 3, 6, 7, do not say 6, 7, do math. 228, you want to subtract it that way, you can do it that way. If you want to decompose it with 367 minus 228 equals, I can have 367 minus 200 because I'm taking out my 200, and that's going to give me 167. So then I bring my 167 down, and I still need to take away 28, so I'm going to take away 20, and that's going to give me 147. Bring my 147 down and subtract 8. Uh-oh, that's not going to be too easy, is it? So if I take away 7, that's going to give me 140, and then I bring my 140 down and take away one more, and that gives me 139. So this is our decomposing strategy. This is what I call the old-fashioned way. And if we think about our popsicle sticks, I can't take 8 from my 7 ones, so I have to mark that out. I have to unbundle a 10. So now it's 5 there, and that becomes 17 ones. And I have 9. I have 3 bundles of 10 left and 100 left. So both of them give me the correct answer. Gabe is trying to solve 246 plus 367. Which equation shows how he could adjust the add-ins to find the sum? So you're going to have to adjust those add-ins. So if I add 4 here, that means I've got to take 4 away here. So let's see. On this one, I added 4 to the first one, and I've subtracted 7, so that doesn't keep it balanced. I added 4 to the first one, and I added 3 to the second. That doesn't keep it balanced. I added 4 to the first one, I took 4 away from the next one. That does keep it balanced. I added 4 to the first one, I added 4 to the second one, but if we add to both of them, then our sum is going to be double what we added higher. So that can't be right. So the only one that could be right is C. Use the bar diagram to help you find the missing number. Well, this is our whole part. So, I know I can either add or I can subtract. Now, if I had 219 and I got to get to 450, I can add 200 to that and get to 419. But I need to get to 450, so I can take 419 and add one more and get to 420. And then I can take 420 and add 30 more and get to 450. Now, if I do my expanded form, I have to put all of what I added to it. So I have 21 and 30, so it would be 231 would be my answer. And if I take 231 away, because of my fact families, I'm going to get my other part. Do you think it makes more sense to decompose both add-ins or adjust both add-ins to solve 388 plus 472? We are just going to add what 388 plus 472 is. Now, here's the thing. When Ms. Haycraft looks at this, if I study this, I automatically see 2 and an 8 makes a 10. So it makes me want to go 390 plus 470. And then if I do that, I can easily decompose and go 300 plus 400 equals 700. 90 plus 90 plus 70 equals 160. And then if I add those two together, I'm going to get 860. Does that make math sense? It does, because that'll be 700. So if I did it that way, now if I wrote it right over top of each other, 388 plus 472, that's a 10, carry my 1, 9, 16, carry my 1, and 8, 860, so it checks both ways. 18. Which of the following equations can you solve this subtraction equation? Which of the following equations can you use to solve this subtraction equation? So, I know this is my whole and I'm taking away a part. So if I add the two parts together, I should be able, so I'm going to put a dot there, should be able to get back to my whole. This one is subtracting and getting to the whole. That's impossible, so that can't work. If I take this away, that doesn't make sense because I don't have enough to take that away, so that one doesn't make sense. If I add my whole to my part, it's going to give me more than that, so therefore the ones that I put a dot beside is actually the correct problem. Enrique read 249 pages of his book in June and 227 pages of his book in July. The book has a total of 638 pages, and Enrique wants to know how many pages he has left to read. Which equation could be used to solve the problem? Now let's think about this. We have, move it down. We have 249 pages in June and 227 pages in July. So we know if we take, let me scoot this back a little bit so you can see it better. If we have a part whole, how we've been doing this whole thing, we know that one part he has already read is 249. Another part is 227. But the book has a total of 638 pages. Well, here's the problem. We need to extend this on out because we have a missing unknown here. So 638 goes from here to here because that's the whole. And we've already got two parts. We need the third part. So after drawing this bar diagram, which set of equations could be used to solve? 227 plus 249 equals 476. Then they take 638 minus 227 to get 4. Does that make my sense? I can see them adding these two parts, and if I add these two parts, I do get 460. Oh, got a 10 there, so I have to move it over. So I do get 476 when I add from here to here. But I still have that missing part there, this part. And I know that I have to subtract it from this. So this way is correct on this one. But then when they get the whole and they take away this part, that's wrong. So they added to get that, and then they used the whole number and took away 476, which is correct. 638 minus 200, no, that one, why would you do that? That doesn't make any math sense whatsoever. And that doesn't make math sense. Oh my goodness, excuse me. All right. Flip the page, and we are on the performance task. the performance task. Shirfan is helping a new pastry shop that has been open for 2 weeks. Pastry shop customers, week, these are the number of weeks. Number of customers, these are the number of customers for that each week. How many total customers did the pastry shop have in weeks 1 and 2? So, how many total customers, so total, that's a keyword, customers did the pastry shop have in weeks 1 and 2? So that means we're going to have to add week 1, which is 324, and week 2, 289. You've got to get the answer for that. You could have used 300 plus 200, which is 500, partial sums. 20 plus 80, ooh, looky there, there's 100. I like that. And then we have our 4 plus our 9, which is 13. So I have 500 plus 100, 600 plus 13 is 613. How many total customers did the pastry shop have in weeks 1 and 2? The pastry shop has 613 customers. I'm running out of room. ERS. What is the difference between the number of customers in week 2? The difference. This is the word that we were struggling with. Remember, difference is the answer to what? Yes, a subtraction problem. So the difference, 324, the difference between 324 and 289. Now there's a lot of different ways we can do that. We know it's 324 minus 289. I'm looking for the answer. I'm going to use the number line. So I know I need to find the difference between 289 and 324. Well, I can't jump 100 because 100 would take me to 389. So I'm going to jump, if I jump 1 plus 1, then I'm going to be at 290. And then I can go, well, a 10 plus 10, that's going to give me 300. And then I can go 20 plus 20, that's going to give me 320. And then I can go 4 more. And so the difference is 20 plus 10 is 30, 34, 35. So the difference is 35. The difference is 35. And if I look at that, does that make math sense? Yeah, because if I add 20 to my 89, I'm going to get 309. And then I still have to go up. Yeah, because I need 11, and then I have 24 left. I need 11 to get to 300, and then I need 24, and 11 plus 24 is 35. So that does make math sense. The pastry shop goal is to have 800 customers within the first 3 weeks. How many customers must visit in week 3 for the shop to reach their goal? Well, we already know, because of part A, they have a total of 613 customers, and we need to get that number to 800. So we know we need the difference between 800 and 613. I'm going to go with my number line again. If I start out at 613, I know I can jump to 713, and that's plus 100. So 713, and if I jump 7, that's going to give me 720, and then I know I need to jump 80 more to get me to 800. So when I add it together, I get 187. So 187 is how many more customers we need to reach our goal of 800. So we need 187 more customers. And D, we've got, if the pastry shop has 847 visitors in the first 3 weeks, which week would have more customers, week 1 or week 3? Oh, they're changing it on us. It's not this one because it's 47 more than 800. In the first 3 weeks, if the pastry shop has this many visitors in the first 3 weeks, which week would have more customers, week 1 or week 3? So this is going to be different. We know week 1 has 324 customers. We need to figure out what it would be if we had 847. So 847 minus 613, because that's how much week 1 and week 2 is, equals what? What is the difference? So we're going to have to draw our number line, start out at 613, and, oh, there's my timer. And then we're going to have to jump. So I already know that if I jump 100, I'm going to be at 713. Then if I jump 7 more, I'm going to be at 720. And then if I jump 80 more, I'm going to be at 800. But I need to get to 847. So I'd have to jump 40 more. And then I'd have to jump 7 more to get to 847. Then add all of these partials up. So 100, and if I add those two, I'm going to get 120. And then if I add my 2 7s, I get 14. So it's 234 for week 3. So week 3 would be 234. So therefore, week 1 would still have more. So week 1 would have more.